أهلا بكم طالبات وطلاب جريد 1 بريب. برحب بكم في حلقة ماث جديدة تحت رعاية وإشراف وزارة التربية والتعليم. والنهاردة في درسنا هنتكلم عن negative integer powers and what is the relationship between the negative and the non-negative integer powers. So let's see them with each other. Negative integer powers. Let's see our warming up for today's lesson. It is about the multiplicative inverse and what is the relationship between the negative power and the multiplicative inverse. What is the multiplicative inverse of 2 over 5? As we know, we are going to flip the rational number. It is 5 over 2. And that's what we will do exactly to find the negative exponent. So, if we have a over b and it is a rational number and the n and the m are non-negative integers, then in multiplication a over b to the power of n times a over b to the power of m is equal to a over b to the power of n plus m, and that's what we know before. So in multiplication we need to add the exponents. Remark that if a is a rational number, non-zero number, and the n is a positive integer, a to the power of negative n is equal to 1 over a to the power of n. So when I have any negative exponents, we need to flip the rational number or flip the fraction. So it is a, actually this a is over 1. Let me write it. This a is over 1. So, and the exponent here is negative. So we are going to flip it. It becomes 1 over a to the power of n. So keep that in mind because we are going to use it now. 3 to the power of 1 is equal to 3. Why? Because we are going to repeat 3 just one time. Then, example 2, 3 to the power of negative 1 is equal to 1 over 3. Why 1 over 3? Because 3 it is over 1 and we are gonna flip it. It becomes 1 over 3. What about 3 to the power of 2? 3 times 3, which is 9. Then 3 to the power of negative 2, it is 1 over 3 to the power of 2, which is 1 over 3 times 3, and that means 1 over 9. Practice. Find the value of each of the following. Number 1. 2 to the power of 3, it means 2 times 2 times 2, which is 8. Number 2. 2 to the power of negative 3. What is the relationship between both of them? Here, this 2 is over 1. Keep that in mind. So immediately flip the fraction when we have negative exponent. So it becomes 1 over 2 to the power of 3 equals 1 over 8. Number 3, 2 to the power of 3 times 2 to the power of negative 3. 2 to the power of 3, we are going to keep it as it is, but 2 to the power of negative 3, we are going to change the position of it. So it is 1 over 2 to the power of 3. And no need to write 1, so we are going to write it immediately at the denominator. And any number over itself equals 1. 2 to the power of 3 over itself, so is 1. Or we can write it as 2 to the power of 3 minus 3, which is 2 to the power of 0 equals 1. Now we have another remark. A to the power of n times a to the power of negative n is equal to a to the power of n plus negative n. So here in multiplication, as we know before, we have to add the exponents, even if we have negative or non-negative integers. So it is a to the power of n minus n equals a to the power of 0 equals 1. Any number to the power of 0 is 1, except 0 to the power of 0. Or we can write it as a to the power of n times 1 over a to the power of n. And then a to the power of n over itself equals 1. So you can write it by adding the exponents or by flipping the negative power, and you will get the same answer in both. Let's watch this video from AKB.
When we multiply two numbers with the same base, all we have to do is write down the base and add the exponents. Let's try it with one of these negative exponents. Suppose we multiply 4 to the power 2 and 4 to the power negative 2. The base is the same, so we write it down and add exponents. 2 plus negative 2 is 0. So the product we're after is 4 to the 0 power, or 1. Put that in the back of your mind while we turn to something different. This time, let's multiply 4 to the power 2 and 1 over 4 to the power 2. This gives us the expression shown, which of course is 1. We could have canceled and gotten the same result. Let's put together the two things we've just done. We started both times with 4 to the power 2. In the first case, we multiplied by 4 to the power negative 2. The answer was 1. In the second, we multiplied by 1 over 4 to the power 2. The answer was still 1. So what could be more reasonable than to conclude that these two are equal? 4 to the power negative 2 equals 1 over 4 to the power 2. This will work every time. Here, for example, we start with 2 to the power 3. Multiply by 2 to the power negative 3, and we get 2 to the power 3 plus negative 3, which is 2 to the power 0, or 1. On the other hand, starting as before, we can multiply by 1 over 2 to the power 3, and again the answer is 1. So 2 to the power negative 3 must equal 1 over 2 to the power 3. Here's the general idea. Suppose you have a number, or for that matter a letter, with a negative exponent. For example, 8 to the power negative 7. Think of the whole business as a fraction with a denominator of 1. Then, to change the sign of the exponent, just invert the fraction. It also works if you start with a positive exponent. For example, 4 to the power 9 equals, and think of it as a fraction with a denominator of 1, invert, it equals 1 over 4 to the power negative 9. It's the inverting that changes the sign. You can go back and forth this way, moving things from numerators to denominators and back again, as long as you change the sign of the exponent each time.
Okay, as you have seen right now, it's up to you to do it by adding the exponents or by flip the negative power, then simplify it. And always keep in mind, when you switch the numerator and denominator, change the sign of the exponent. Okay, practice. Find the value of each of the following. Number 1, 6 to the power of 9 times 6 to the power of negative 7. Okay, I said it's up to you to do it by any way. Add the exponents immediately or flip the negative power. I solve it here by the flipping the negative power. 6 to the power of 9 times 1 over 6 to the power of 7. And in division, we will subtract the exponents, so it is 6 to the power of 9 minus 7, which is 6 to the power of 2, which is 6 times 6 equals 36. Number 2. 11 to the power of 8 over 11 to the power of 10. Here I need you to pay more attention. We have to start the subtraction from the top. So here we have, let me circle it. Here I have 11 to the power of 8. So it is 11 to the power of 8 minus 10. Some of the students do the greater number first. No, it's not a rule. So I have to start from the numerator. 8 minus 10, which is negative 2. And here we have negative power, so immediately flip it. It becomes 1 over 11 to the power of 2, which is 1 over 11 times 11 equals 1 over 11, 1 over 121. Okay, let's take more exercises on the board. Here, let's take this one. Here, practice. Find the value of each of the following. Number 1. 2 to the power of negative 4 times 2 to the power 7 over 2 to the power of negative 2, all of them to the power of negative 3. As we said, it's up to us to do it by adding the exponents or flip one. I'm going to do it by the first way. Okay, here we have 2 to the power of negative 4. As we said, when we have negative power, switch or change the position of it from the numerator to the denominator. So I'm going to put it down, okay, and this 2 to the power of negative 2, it is down, so raise it up. That is the first step. Let's see the answer. Here, 2 to the power of negative 2, I raised it up, and 2 to the power of negative 4, I put it down. And I kept 2 to the power of 7 as it is. Now we have multiplication with the same base, 2 and 2 here, so immediately add the exponent. So it is 2 to the power of 2 plus 7 over 2 to the power of 4. And I kept the negative 3 above all of them as it is. So here 2 to the power of 2 plus 7 is 9, and 2 to the power of 4 as it is. Then in division we have to subtract the exponent, so it becomes 2 to the power of 9 minus 4, which is 2 to the power of 5, all of them to the power of negative 3. And as we know, when we have two exponents above each other, we need to multiply them, so it becomes 2 to the power of negative 15, which is 5 times negative 3. And here this 2 is over 1. It doesn't have a denominator, so immediately flip it, so it becomes 1 over 2 to the power of 15. Can we solve it by another way? Of course, yes. Let me do it by another way. Here, I can write 1, 2. And here, this negative 4 and 7, we need to add them. And what about negative 2 here? Keep it as it is right now. Okay, so it is 2. Negative 4 plus 7. Yes, I forgot to put all of them to the power of negative 3. Always we have to start from inside the brackets. So it is 2 to the power of 3. Why 3? Negative 4 plus 7, sign of bigger than subtract. 7 is the bigger number, so subtract from it 4, and 2 to the power of negative 2 as it is, then all of them to the power of negative 3. Okay, now we have 2 to the power of 3 over 2 to the power of negative 2. Raise this up, so it becomes 2 to the power of 3 times 2 to the power of 2, all of them to the power of negative 3, which is, in multiplication, add them, so it becomes 2 to the power of 3 plus 2, which is 5, all of them to the power of negative 3. Then I have two exponents above each other, so immediately multiply them, so it becomes 2 to the power of 3 times negative, 5 times negative 3, which is negative 15, and then flip this fraction, so it becomes 1 over 2 to the power of 15. We got the same answer. Let's return back to it. So don't forget it, it's 1 over 2 to the power of 15. Let me make it. Here it is. We got the same answer. It is 2 or 1 over 2 to the power of 15. So it's up to you to do it by any way of them. Now, another one. Complete. Here, 3 over 7 to the power of negative 2. I changed the exponents. It becomes, it was negative 2 and it becomes 2. We changed the exponents, so immediately we need to flip the fraction or change the position of the numerator and denominator. So it was 3 over 7, so we are going to write it as 7 over 3. Okay, so always keep in mind when we flip the numerator and denominator, change the sign of the exponent. Now, distribute this 2 or 7 over 3 times itself 2 times, so it becomes 49 over 9. 7 to the power of 2 is 49, 3 to the power of 2 is 9. Number 2. 7 to the power of negative 3 is 1 over what? Here. So I changed the position of numerator and denominator, so immediately change the sign of the exponent. So it becomes 1 over 7 to the power of 3. Number 9. Here it was positive 9 to the power of 2. Then I did it as 1 over 9 to the power of what? Also we changed the sign, so it becomes 9 to the power of negative 2. What do you observe between 2 and 3? Here it was negative and I put it down as positive. In number 3 it was positive and I put it down with negative. So we have a rule. When we change the position from numerator to denominator or vice versa, immediately change the sign of the exponents. Okay, let's solve one more. Let's take this remark with each other. If we switch the numerator and denominator, change the sign of the exponent. That's what we said right now, okay, and always keep it in mind. Now, choose the correct answer. Number 1, 4a to the power of negative 6, and I have 3 choices. Okay, I need you to focus with me about the negative power. This 4, it doesn't have an exponent, so keep it at the same position. So I'm going to keep 4 as it is. But what about a? A is to the power of negative 6. This a is over 1, so immediately flip it. It becomes 1 over a to the power of, think with me, to the power of 6. Why? Because I've changed the position of it, so change the sign of the exponent. So the correct answer is number 3. A to the power, 4a to the power of negative 6 is equal to 4 over a to the power of 6. Okay, and here the common mistake, some of the students change the position of 4. No, please, because 4, it doesn't have an exponent. Number 2. If a equals 0, then a to the power of negative 3 is equal 0, undefined, or 1. Okay, let's do it with each other here. This a to the power of negative 3, it means 1 over a to the power of 3. And a is given. A is 0. 1 over 0 to the power of 3, which is 1 over 0. And any number over 0 is undefined. So the correct answer is undefined. Let's take one more. Simplify and write the result in the term of a positive exponent. Number 1, c to the power of 9 over c to the power of 7. As we said, we have to start from the top. So it becomes c to the power of 9 minus 7, which is 2, c squared. Number 2, c to the power of 7 over c to the power of 9. Also start from the top. So it becomes c to the power of 7 minus 9, which is negative because we start with a small number in subtraction. So it is c to the power of negative 2, which is 1 over c to the power of 2 according to our remark. Change the position if we have negative exponent. Number 3, x to the power of negative 2 over x to the power of negative 6, all of them to the power of negative 3. So we are going to change the position of x to the power of negative 2, put it down, and x to the power of negative 6, raise it up. X to the power of 6 over x to the power of 2, all of them to the power of negative 3, which is x to the power of 6 minus 2, because in division we have to subtract the exponent. And then we have two exponents above each other, so multiply them, x to the power of negative 12. Okay, we have negative power, so 1 over x to the power of 2. That's all about today's lesson. I hope it was clear for everyone, and good luck. Bye-bye.